You see this term everywhere, right? AI model. It's on the news, it's on your phone, but what does it actually mean? Well, in this explainer, we're going to pull back the curtain and demystify that exact question. I mean, seriously, we hear about language models, prediction models, image models. It feels like there's a new one every single week. But what are we really talking about when we use that word model? For most of us, let's be real, it feels like this mysterious black box. You feed some data into one side, some kind of weird digital magic happens inside, and poof, an answer pops out the other side. But here's the thing, it is not magic, not at all. So right now, we're going to open that box and take a good look inside. All right, let's dive in. We're going inside the black box. And what you're going to find is that this is way less about magic and a whole lot more about making reality just a little bit simpler to understand. Okay, here's the big secret, the key to the whole thing. A model is just a simplified representation of reality, and it's built to do one thing, make predictions. That word, simplified, that's everything. A model isn't trying to capture every single detail of the real world. No way. It just grabs the parts it needs to do its job. You know, a perfect way to think about this is a toy car. It looks like a car, its wheels turn, but that's kind of it, right? There's no engine under the hood, and no AC, no radio. It's been simplified on purpose so that it's useful for its one job, being a toy. An AI model is the exact same idea. It captures the essence, not every little detail. So let's just throw that whole magic black box idea out the window. It's way more helpful to think about a model as a simple three-part recipe. And once you get this recipe, you pretty much get how all models work. And here's the recipe. It's only got 3 steps. First step, the input. These are your ingredients, the data you're starting with. Step 2, the model itself. This is the recipe card, the instructions, the logic that tells you what to do with those ingredients. And finally, the output. This is your finished meal, the prediction or the decision that the model spits out. Ingredients, recipe, meal. See, it's that straightforward. Okay, so now that we've got the recipe down, let's look around. Because I promise you, once you know this pattern, you're going to start seeing it absolutely everywhere. In tech, you use every single day. Take your weather app, for instance. The input, the ingredients, is all the current data. The temperature, the humidity, pictures of the clouds. The model, the recipe, is this huge system that has studied decades of weather patterns. It knows that when you mix these specific ingredients, you usually get a certain result. And the output, the final dish, is that prediction, 80% chance of rain. Or how about the GPS on your phone? The input is your location, where you want to go, and all that live traffic data. The model is basically a digital map mixed with a super fast calculator that's figuring out thousands of possible routes. And the output is a prediction, turn left in 200 feet. It's predicting that this one turn is the key to the fastest route. And hey, it's not just for serious stuff. Think about a bad guy in a video game. The input is what you're doing, where you are, your health, all that. The model isn't some super genius brain. A lot of the time, it's just a simple list of rules, like a decision tree, you know? If the player gets close, then swing the sword. If they're far away, then shoot an arrow. The output is what the enemy actually does on screen. It's just following its simple little recipe. So models are simple, they're powerful, and they're everywhere. But here's the catch. Their greatest strength, that simplification we talked about, is also their biggest, most dangerous weakness. And this brings us to a really crucial warning. The legendary statistician George Box gave us what I think is the golden rule for all of this. He said, all models are wrong, but some are useful. Just let that sink in for a second. All of them, every single one, is wrong. So why? Why are they all wrong? Well, it goes back to what we said. They are simplified versions of reality. Think about a map again. A map is a model of the world. Now imagine you had a perfectly accurate map, one that was the actual size of the Earth. It would be totally useless, right? You couldn't fold it, you couldn't put it in your pocket. A map's wrongness, the fact that it's simplified, is exactly what makes it useful. But this idea that all models are simplified leads to the single biggest flaw they have. It's a classic phrase in computer science, and you've probably heard it before. Garbage in, garbage out. All it means is that a model can only ever be as good as the data you feed it. To see just how bad this can get, let's imagine a crazy scenario. Say we build a weather model, but we only train it on data from the Sahara Desert. Then we take that model and ask it to predict the weather on a cloudy day in London. What's it going to say? Well, since the model has never even seen rain in its data, it literally can't predict it. It'll look at those gray London clouds and make the only prediction it knows how to make: sunny. Garbage data in, garbage prediction out. So here's the takeaway. Every AI recommendation, every forecast, every single chatbot answer you get, it's all coming from a model. And by definition, that model is an incomplete, simplified picture of the world. Which leaves us with a really important final question to think about. If all models are wrong, how do we figure out which ones are useful enough to actually trust?